Hey guys, welcome back, I'm Jay. In this episode, we're gonna look at RDS MultiAZ deployments and read replicas. RDS provides high availability and failover support for DB instances using MultiAZ deployments. In a MultiAZ deployment, RDS automatically provisions and maintains a synchronous standby replica in a different availability zone. Data in the primary DB instance is synchronously replicated to the standby instance, to provide data redundancy, eliminate I/O freezes, and minimize latency spikes during system backups. Each AZ runs on its own physically distinct, independent infrastructure, and is engineered to be highly reliable. In case of an infrastructure failure, RDS performs an automatic failover to the standby, or to a read replica for Amazon Aurora. The endpoint for your DB instance remains the same after a failover, so that you can resume database operations as soon as the failover is complete. The main purpose for MultiAZ deployments is for high availability and disaster recovery. MultiAZ deployments for MariaDB, MySQL, Oracle, and PostgreSQL DB instances use Amazon's failover technology. Microsoft SQL Server DB instances use SQL Server database mirroring, or always-on availability groups. With MultiAZ deployments, for the MySQL, MariaDB, Oracle, and PostgreSQL engines, the backup is taken from the standby instance. Unlike single AZ deployments, I/O activity is not suspended on your primary during backup for MultiAZ deployments. However, you might still experience elevated latencies for a few minutes during backups for MultiAZ deployments. DB instances using MultiAZ deployments have higher write and commit latency compared to single AZ deployments, due to the synchronous data replication that occurs. When you deploy MultiAZ for production workloads, AWS recommends that you use provisioned IOPS storage, and DB instance classes that are optimized for provisioned IOPS for fast and consistent performance. In the event of a planned or unplanned outage of your DB instance, RDS automatically switches to a standby replica in another availability zone if you have enabled MultiAZ. RDS handles failovers automatically, so that you can resume database operations as quickly as possible without administrative intervention. The time it takes for the failover to complete depends on the database activity and other conditions at the time the primary DB instance became unavailable. Failover times are typically 60 to 120 seconds. However, large transactions or a lengthy recovery process can increase failover time. When the failover is complete, it can take some extra time to see it's in the new availability zone from the AWS console. The primary DB instance switches over to the standby replica if there is an outage in an availability zone, or if the primary database instance fails, including network connectivity loss, or hardware failure. Failover also happens in the event of a planned outage, for example, when the DB instance server type has changed, or when the operating system of the DB instance is undergoing software patching. You can also force a manual failover by using reboot with failover. RDS Read Replicas provide enhanced performance and scalability for DB instances. Read replicas make it easy to scale out for read-heavy database workloads. You can create multiple replicas of the source DB instance, and serve high-volume read-only traffic from multiple copies of your data, thereby increasing aggregate read throughput. Updates made to the source DB instance are asynchronously copied to the read replicas. You can create read replicas from a primary DB instance, or from another read replica. When you create a read replica, you first specify an existing DB instance as the source. RDS takes a snapshot of the source instance and creates a read-only instance from the snapshot. RDS then uses the asynchronous replication method for the DB engine, to update the read replica whenever there is a change to the source DB instance. The read replica operates as a DB instance that allows only read-only connections. Applications connect to a read replica the same way they do to any DB instance. RDS replicates all databases in the source DB instance. RDS supports both same-region read replicas and cross-region read replicas. So you can create read replicas either in the same AWS region as the source DB instance, or in a different region. For non-Aurora DB engines, you can add up to 5 read replicas to each DB instance. For Aurora, you can add up to 15 read replicas to each DB instance. You can also promote read replicas to become standalone DB instances, for example, as a disaster recovery solution if the primary DB instance fails. However, this process may take longer than automatic failover using MultiAZ deployments. All RDS DB engines support read replicas, include Amazon Aurora. Cross-region read replicas means a source DB instance can have read replicas in multiple AWS regions. RDS cross-region replication supports DB instances for MariaDB, MySQL version 5.6 and later, PostgreSQL, Oracle, and Aurora. Currently Microsoft SQL Server is not supported by cross-region replication. You can only create a cross-region RDS read replica from a source DB instance, that is not a read replica of another DB instance. You can expect to see a higher level of network latency for any read replica that is in a different AWS region than the source instance. This network latency comes from the long network channels between regional data centers. When the source of a cross-region read replica is deleted, for MariaDB, MySQL, and Oracle DB instances, the read replica is promoted. For PostgreSQL DB instances, the replication status of the read replica is set to terminated, and the read replica isn't promoted. RDS MultiAZ deployments and read replicas both can replicate data. However, they serve different purposes. The main purpose of RDS MultiAZ deployments is for high availability and disaster recovery. Suppose you have a primary database in one availability zone and a standby database in another AZ. New data are inserted into a primary DB instance. Data in the primary DB instance are synchronously replicated to the standby replica to provide redundancy. All data operations including reads and writes are directly performed against primary DB instance. In the event of an outage, the primary DB instance stops responding. RDS automatically switches to a standby replica in another availability zone. RDS read replicas provide high performance for read-heavy operations, and offload read operations from primary DB instance. Data in the primary DB instance are asynchronously replicated to read replicas. These read replicas provide read-only operations and serve high-volume read traffic from multiple copies of data, thereby increasing aggregate read throughput. Read replicas can also be promoted as standalone DB instances when needed. Each Aurora DB cluster has one primary DB instance. The primary DB instance supports read and write operations, and performs all of the data modifications to the cluster volume. Each Aurora DB cluster can have up to 15 Aurora replicas, in addition to the primary DB instance. Aurora replicas connect to the same storage volume as the primary DB instance, and support only read operations. Here is relationship between the cluster volume, primary DB instance, and Aurora replicas in a single master Aurora DB cluster. We have one primary DB instance and read replicas across multiple availability zones. A cluster volume spans multiple AZs, with each AZ having 2 data storage nodes. When data is written to the primary DB instance, Aurora synchronously replicates the data across availability zones to these storage nodes. You can place Aurora replicas in different availability zones to provide high availability. These read replicas offload read operations from the primary DB instance. If the primary DB instance becomes unavailable, Aurora can automatically failover to an Aurora replica. An Aurora replica is promoted to the primary instance. If there is no Aurora replicas, the cluster will be temporarily unavailable during the DB instance recovery. To provide high availability, AWS recommends that you create one or more replicas in different availability zones. They should be of the same DB instance class as the primary instance. Aurora cluster provides the separation of compute capacity and storage. An Aurora cluster with only one DB instance is still a cluster, because the underlying storage volume involves multiple storage nodes, distributed across multiple availability zones. In this episode, we've learned RDS MultiAZ deployments and read replicas. RDS MultiAZ deployments provide high availability and failover support for DB instances. In a MultiAZ deployment, RDS automatically provisions and maintains a synchronous standby replica in a different availability zone. Data in the primary DB instance is synchronously replicated to the standby instance, to provide data redundancy. In the event of planned or unplanned outage, RDS handles automatic failover. The endpoint for your DB instance remains the same after a failover. RDS read replicas provide enhanced scalability for DB instance, to improve performance for read-heavy database workloads. Updates to the source DB instance are asynchronously copied to the read replicas. You can create read replicas from a primary DB instance or from another read replica. RDS supports both same region and cross-region read replicas. For non-Aurora DB engines, you can add up to 5 read replicas to each DB instance. For Aurora, you can add up to 15 read replicas to each DB instance. Okay, That's all for RDS MultiAZ and Read Replicas. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.